Welcome to part 2 of the further integration topic, where we are going to be looking at a method of integration called integration by substitution. Some integrals are pretty tricky when we look at them. They don't fit any of the common rules that we've seen so far for integration. And so what we can do is choose an appropriate substitution to make our integral a little bit easier. First, we're going to start off with an example that can be done using the chain rule. So we have the integral of 12x squared outside of root 4x cubed plus 1. Before we use the method of substitution, pause the video and have a go at this question using the chain rule. All right, time to use the substitution method. And in the Extension 1 course, the substitution will be given to you. However, I do encourage you to see if you can identify what an appropriate substitution would be yourself. Now notice that we are introducing a new variable, in this case u, and so we will be integrating with respect to u and not x, meaning this dx will need to be replaced with a du term. So let's look at our substitution, and we can derive this equation and find du dx. In this case, we will get 12x squared. And treating this like a fraction, we can see that du is equal to 12x squared dx. If we look back at our original integral, we can see there is a 12x squared here and a dx here. So rewriting our original integral like this, we can clearly see that 4x cubed plus 1 will be replaced by u, and the 12x squared dx will be replaced with du. So let's make the substitutions. Once we've done this, we can see that our integral becomes much more manageable. So the square root of u, we can rewrite that as u to the power of a half. And integrating u to the half, we get u to the power of 3 on 2 over 3 on 2, plus our constant of integration. Tidying up a little bit, we see that our 2 comes on the top of the fraction, and instead of u to the power of 3 on 2, we will rewrite this using the radical form. So this is u cubed under the square root. Now 3 is on the denominator, and we still have our constant. Now the variable u was introduced by us to make this integration easier, but we still want our final answer to be in terms of the original variable x. So the last step is to undo the substitution. We said that u was equal to 4x cubed plus 1, and so we will put that back in instead of u. And there is our final answer. Hopefully, this is something similar to what you got when you attempted the problem using the chain rule. And so now we can see that the substitution method is completely valid. Let's now have a look at a second example where we can't do it using any of the common rules. Example 2, we have the integral of x outside of root x plus 1. Now I will give the substitution in just a sec, but what do you think it might be? What would be an appropriate substitution that might help us? We are going to use u equals x plus 1. Now in this case, the derivative du dx is simply 1, meaning that du is equal to dx. So let's go ahead and rewrite our original integral, and let's replace what we can. X plus 1 is going to be replaced with u. And dx, well, we just saw that that is equal to du. But what about x? See, in our first example, it worked out really nicely. But this one, how are we going to replace the x? Well, if we look back at our original substitution, our original relationship between u and x, we notice that we could make x the subject. And so we would get x is equal to u minus 1. Meaning we can now replace this x with u minus 1. Noting that the square root of u is u to the half, we can then evaluate this integral by expanding the brackets. So when we do our first expansion, we have u multiplied by u to the power of a half. So that's u to the 1 times u to the half. So let's add those powers together, and we can get u to the power of 3 on 2. The second one is just negative 1 times u to the half. So we have u to the power of 5 on 2 over 5 on 2 minus u to the power of 3 on 2 over 3 on 2 plus our constant. Tidying things up a little bit and putting it back into radical form, we get 2 over 5 times the square root of u to the 5, and we get 2 over 3 times the square root of u cubed. Our final job is just to undo the substitution that we started with originally. So remember, we use the substitution u equals x plus 1, and so we can go and replace u with that x plus 1. And once we've done that, we have our final solution. Good luck with the exercise questions.